here will be superior colliculus of the tectal lamin of the medial brain. This will be inferior colliculus of the tectal lamin of the medial brain. This will be pons, this will be medulla oblongata. This will be thalamus, and this will be the cortex of the brain. Cortex of the brain. Here will be also thalamus, do you see? Here will be medial geniculate body, and here will be cortex, and here will be cortex. You can see, this is thalamus, this is medial geniculate body, do you see? This is thalamus on opposite side, this is cortex on opposite side. If you remember, cochlea, this is hidden part of the vestibular cochlear nerve. The vestibule and semicircular canals, they include equilibrator receptors. At first we will speak about hidden part. If you remember, in the membranosus labyrinthis of the cochlea, is placed cortive organ. Cortive organ, it consists receptors. From receptors, do you see? From receptors will begin, do you see, dendrites, which inside, in the spiral, in the space of the spiral lamin, they have their bodies. The bodies complete into the spiral ganglion, which by spiral direction, like колбаса, do you see, will pass through the space of the spiral lamin around of the mediolus. You can see this is receptor, and this is bipolar cells. This is body which is placed in the space of the spiral membrane. Now I will draw, here we have the sum, do you see, thousands of the neurons, do you see, but I draw only two by scheme. From base of the mediolus will exit the cochlear nerve, which is formed by some thousands of the axons of the, do you see, bipolar cells. And this, do you see, and these axons complete into the cochlear part of the vestibular cochlear nerve and enter, do you see, inside into the internal acoustic meatus from, do you see, from cochlea, and will exit from external acoustic meatus into the cranial cavity and will direct to the nuclei. You can see this is internal acoustic meatus, and from this inside will exit here the cochlear part of the vestibular cochlear nerve. Here do you see biggest open on, do you see? Last time we studied facial nerve enters and do you see vestibular cochlear nerve exits. Okay. You can see, and it comes to the nuclei. They are dorsal cochlear nucleus and ventral cochlear nucleus. This will be, do you see, body of the first neuron of the hearing way. This will be body of the second neuron of the hearing way. This is I stand between you, because this is my left ear. Do you see? From my left ear, do you see, will direct to the brain 100% of the hearing. 100% of the hearing. And do you see, they will come to the dorsal cochlear nucleus and ventral. And only, do you see, 20% will go to the cortex on each side, from left ear to the left brain. From cochlear ventral nucleus, the sum, do you see, portion will go for the production of the synapse with dorsal olive nucleus of the trapezoid body. Now, for my students, I said, we have nucleus olivaris dorsalis, nucleus olivaris ventralis. For your easy memory, is easy to remember. dorsal nucleus of the trapezoid body, ventral nucleus of the trapezoid body. And after this, we'll go to the opposite side. From ventral cochlear nucleus, the sum... Я тебе сказала, что цель, что
I was correct the other day. I wrote dorsal leaf nucleus and ventral leaf nucleus. Then you said dorsal nucleus of trapezoid. She said both is the
Да,
same.
четверо детей одного закончила институт, да. Ну, в смысле, не закончила, а на третьем, да? Да, на втором. Look is here.
That day she will say it's
From
dorsal.
the cochlear ventral nucleus, another synapse will be with ventral nucleus of the trapezoid body on its side. And after that, we'll go to the opposite side. From this cochlear ventral nucleus will go for the production of the synapse with dorsal nucleus of the trapezoid body on opposite side. And the same will do with ventral nucleus of the trapezoid body on opposite side. You can see cochlear ventral nucleus produces synapses with all nuclei of the trapezoid body. Two nuclei, dorsal and ventral, on each side, and two nuclei on opposite side. Look at here, dorsal cochlear nucleus, 20% of the fibers directed by its side to the brain, and another 80, do you see? And another 80 lie on the floor of the fourth ventricle, and by median dorsal groove of the pons, it enters inside and completes into the bundle with a portion of the hidden portion which exits from opposite side before it. Listen to me, you can see from cochlear ventral nucleus and from cochlear dorsal nucleus, we brought 80% of the hearing to the opposite side. And here we have, do you see, the same nuclei, dorsal nucleus and ventral nucleus. 20% will complete into the common hearing portion, 80 and 20 will be 100. And my right hemisphere will get from left ear, this is through the trapezoid body, and through the dorsal nucleus will get, this is the 80% of the information, and from each side will get 20% of the hearing information. Together will be the 100. Do you see? But this will do the same. What is trapezoid body? This is crossing of the nerve fibers from cochlear ventral nucleus from right side and from left at the nuclei. Do you see? This is trapezoid body, which is placed in the center of the pons. And this is hearing object, which is formed by nuclei and fibers. Listen to me. Here we have, do you see, the fibers, nerve fibers, which exit from pons above, and the common way of the hearing from opposite side and from each side above than the pons is called lateral lemniscus. Sharuch, for you, I explained you when we studied the medial brain. What is medial lemniscus? Medial lemniscus, I will recollect you. This is common way of the superficial and deep sensitive above than the medulla oblongata. And the lateral lemniscus, this is common way of the hearing from opposite side 80% and from each side 20% above than the pons. Look please at lateral lemniscus. Do you remember we studied with you optic nerve? Do you remember we studied with you optic tract? Optic tract. Do you see? Do you remember we studied with you olfactoric tract? Optic tract, what it did? It divided into three portions, which directed to the different subcortical centers for the production of the different functions. You can see lateral lemniscus, like optic tract, it gets information from both ears. Do you see? And it divides into the, do you see, inferior, into the portion which goes to the inferior colliculus, do you see, of the lamina tecti for the production of the for the production of the hear and start reflex. Madam Елена explained you what is hear and start reflex. Not, my dear, no. Do you see? And vision start reflex. You know, vision you know, and hearing not. Do you see? You do you see reflex? Do you see? No, I said if you will listen exclusion. This is hear and start reflex. From inferior colliculus the direct tectospinal way for production of the hear and start reflex if it begins from inferior colliculus. If it begins from superior colliculus, it will do vision start reflex. You can see the one portion of the lateral meniscus will go into the inferior colliculus for production of the hear and start reflex. Another will go into the lateral geniculate body. Into the lateral geniculate body. Oh, excuse me, into the medial geniculate body. Lateral, this is for the vision. Into the medial geniculate body. And after that, will go into the superior temporal gyrus for the concrete analysis. And after that, we'll go into the superior temporal gyrus for the concrete analysis of the sound. And the third part of the meniscus lateralis will go. For what it goes into the middle geniculate body? What? Medial and why vision? We speak about here now. For what it come? For what it come into the middle geniculate body? When we studied the brain, I explained you. Geniculate bodies decide what is important information, what is
important
not.
and what is not important.
What? Now I listen my voice, your voice. We have around us some another, do you see, sounds, do you see? And the middle geniculate body decides, do you see, about what sound, what voice, what sound is important for me, what not. Another portion will go into the triangle of Lemnisce. Triangle of Lemnisce. For what? And from triangle of Lemnisce it will go also into the superior temporal gyrus. What triangle of Lemnisce does? It differentiates the sound, microsound, or do you see, and we cannot, do you see, understand it, do you see, and the, do you see, normal sound. You can see this is whole hearing part. This is whole hearing part. And this is called hearing, do you see, norm or hearing way. The body of the first neuron is placed, do you see, in the spiral ganglion, which is placed inside in the spiral membrane of the cochlea. The bodies of the second neuron, they are placed in the cochlear dorsal and ventral nuclei. The sum bodies for the one part will locate for the third neurons in the trapezoid body. From dorsal nucleus cochlear, we don't have the third neuron. And the fourth neurons for the ventral cochlear nuclei will locate in the subcortical centers for the production of the sum function. This will be inferior colliculus of the thalamus, this will be medial geniculate body, and this will be triangle of Lemnisce. From medial geniculate body and from triangle of Lemnisce will go into the cortex for the concrete analysis. From inferior colliculus will go for the production of the vision start reflex.
Triangle of Lemnisce.
Triangle of Lemnisce. You will get brainstem model, and I will show superior colliculus or superior peduncle of the cerebellum, cerebral peduncle, and inferior brachium. Так, my dear, about what I want to inform you. Что ты хочешь, Сренитки? Сренитки, I cannot produce attention today for you. On Tuesday. Why? Because now I explain material for my students, and after that I will repeat it. Oi, 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 oi.
Who put all these things here?
Sharu.